Hey guys, today we're going to be talking about conditions of parallelograms, and we're just going to go through a few examples and show if something is a parallelogram or it is not. Okay, so number one, it says that show that JKLM is a parallelogram when A equals 3 and B equals 9. Okay, so the first thing you need to know is that a quadrilateral is a parallelogram if its opposite sides are congruent. So that's what we're looking for here. Okay, so let's go ahead and plug in the A's for the A section, and they both need to be congruent. So we have 15A minus 11, and we're going to plug in a 3. Okay, so 15 times 3 minus 11, and 15 times 3 is 45, and minus 11 is 34. So that side is 34. Okay, let's try the other side. Okay, so we have 10 times 3 plus 4. 10 times 3 is 30. Add 4, you get 34. Okay, so those two sides are congruent, so that's good. Okay, and we know that B is 9, so let's try the B's. Okay, so let's try this one first up top. So we have 5 times 9 plus 6. 5 times 9 is 45, and add 6 and you get 51. Okay, so this side is 51. Let's try the last one. Okay, so we have 8 times 9 minus 21. 8 times 9 is 72, and if you subtract 21, that gives us 51. Okay, so since both sides, or opposite sides, are congruent, this is a parallelogram. Okay, so this is a parallelogram. Okay, so that's number one. Number two, we want to decide if PQRS is a parallelogram, and we need to figure out if opposite angles are congruent this time. Okay, so if opposite angles are congruent, then you have a parallelogram. Okay, so this time our x is 10. So let's go ahead and actually let's plug in for our y's first. Our y is 6.5. So we're going to start with this guy. So 6 times 6.5 plus 7. And if you multiply 6 times 6.5 plus 7, that ends up giving us 42 degrees. Excuse me, 46 degrees. Okay, so that first angle is going to be 46 degrees. 6 times 6.5 plus 7. Let's try the one opposite from that. If we do 8 times 6.5 minus 6, that would end up giving you, what is that? 8 times 6.5 minus 6, it's also 46. Okay, so far we both have 46 for our angles. All right, since both of those are congruent, we can go ahead and move on to the x's, and we know that x is 10. So we're going to use it with our 15x minus 16. So 15 times 10 minus 16, and 15 times 10 is 150 minus 16. That's going to give us 134 degrees. Now, we don't have an opposite angle for the x's, and we know that these two were congruent. Okay, but we don't have any variable or anything to plug in for angle P, so we need to decide it some other way. Okay, so we see that this angle is 134, and this angle is 46. Well, since 134 plus 46 is 180, we know that those two angles are supplementary. Therefore, that tells us that this also has to be 134 degrees. Okay, so since both sets of angles are congruent to each other, you have a parallelogram. So this is a parallelogram. Okay, so that was kind of a mouthful. So if you need to go back and rewatch, then that is fine. All right. Next question, it says, determine if the quadrilateral must be a parallelogram. Well, you know that it's a parallelogram if its consecutive angles are supplementary. So let's see if they are. Okay, you have 107, and if you add 83 to, or 73 to that, that will give you 180. Okay, you also see that your opposite angles are congruent. And since those opposite angles are congruent, it would also be a parallelogram. So this is a parallelogram. Okay, the next one. Let's determine if this quadrilateral is a parallelogram. Well, it gives us opposite sides that are congruent, which is great. But to determine if something's a parallelogram, you have to have two sets of opposite sides that are congruent for a quadrilateral. And since we don't know if these are, you can't say that it is a parallelogram. So this, to our knowledge, is not a parallelogram. Okay, so relook through these few problems here and make sure you get everything down. All right, the next one says determine if the quadrilateral must be a parallelogram. Well, let's look at it. Okay, we have two triangles, and basically we need to know if these guys are congruent. Well, since you have two sets of triangles and you have one set of congruent angles, two set of congruent angles, if you have two sets of congruent angles, that means the third set must be equal. Okay, and since you have these guys right here being congruent, and this whole thing would then be congruent, you know that you have opposite angles that are congruent, and that would indicate to us that this is, in fact, a quadrilateral. So this is a quadrilateral. Okay, last example we're going to go through. It says, show the quadrilateral JKLM as a parallelogram by using the definition of a parallelogram. Okay, so let's plot all these points. We've got -2, -1, and that's A. So -2, -1, that's A. We've got -7, -5. 1, 2, 1, 2, 3, 4, 5, 6, 7. Oops, I'm sorry, this is -7, -5. Okay, so go over 7, go down 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Sorry about that. Okay, so that's our second one, which was B. And our last two are -3, -17. Okay, so we have -3 and then -17 apparently would be way down here. I'm not sure why we didn't make a bigger graph. And our last one is 2, -13. Okay, so we're just going to have to do a little bit of guessing here. Okay, so we want to determine if this is a parallelogram. Okay, and basically, we just need to decide if both of the slopes of opposite sides are congruent. Okay, so let's see if that happens by finding the slopes of each of our four segments here. Okay, so remember your slope formula is y2 minus y1 over x2 minus x1, and we're going to do that for each of these sets of ordered pairs. Okay, so our first set, we're going to look at A and B. So if you plug that in, that would give us -5 minus -2 over -7 minus. Excuse me, I'm struggling today. Okay, so you would have, let's go back a little bit. Let's try that again. Hey, if you did that, it would be minus 5 minus minus 1, and then minus 7 minus minus 2. Okay, and if you calculated the slope for that, on the top you'd have minus 5 minus minus 1, so you'd have minus 4. And on the bottom, you'd have minus 7 minus minus 2, which would be negative 5. And of course, those would cancel out, and you'd have a slope of 4/5. Okay, so AB would have a slope of 4/5. Okay, let's try BC. Okay, so BC, if you plug those in, you would end up having negative 17 minus minus 5 over negative 3 minus minus 7. Tons of negatives. Okay, so if you have negative 17 minus minus 5, that'll give you negative 12. And negative 3 minus minus 7 will give us 4. And negative 12 divided by 4 would give us a slope of negative 3. Okay, so BC would give us a slope of negative 3. So let's go ahead and label these. And we got A, B, C, and D. And thus far, we've found that our slope for AB is 4/5. And we found that our slope for BC is negative 3. Okay, now let's figure out what our slope for CD is this time. Okay, so CD, remember we're using y2 minus y1 over x2 minus x1, and you're going to be doing negative 13 minus minus 17 over 2 minus minus 3. Okay, negative 13 minus minus 17 would give us 4. And 2 minus minus 3 would give us 5. Okay, so our CD is going to be 4/5. Okay, so you can see that our first set of opposite sides have the same slope, which is what we're looking for. Now we need to see if AD has the same slope as BC. Okay, almost done here. Okay, so if we have AD, we have minus 13 minus minus 1 over 2 minus minus 2. So minus 13 minus minus 1 would give us negative 12. And 2 minus minus 2 would give us 4. And then negative 12 divided by 4 would give us a negative 3. So if I plug that in, you have a slope of negative 3. And we see that both sides have the same slope. And since that is the case, this is a parallelogram. So this is a parallelogram. Okay. All right. See you later.